Hi, my name is Manish Gupta, and in this video, I'm going to talk about Llama 3.2 models. Okay, so Llama 3.2 consists of two kinds of models, text-only models as well as vision models. So let's first understand how are the Llama 3.2 text-only models trained, right? So as I mentioned, Llama 3.2 has these two things, text-only model checkpoints, which are 1 billion and 3 billion parameters in size, right? And then there are vision LLMs as well, which are 11 billion and 90 billion in size. The interesting part is that for all of these, pre-trained as well as instruction-tuned versions are publicly available. Right? So specifically about these text-only models, which are 1 billion and 3 billion in size, the models have a context length of 128K tokens. So that's a pretty large context length, suitable for many use cases where the input size is expected is large. Right? So they also can support multilingual text generation and tool calling abilities. So these are multilingual models and also support tool usage. Right? Um, so from a performance perspective, what they found is that the 3 billion checkpoint, the larger of their text model checkpoint, outperforms Gemma to 2.6 billion parameter model and 3.5 mini models on various kinds of tasks like following instructions, summarization, prompt rewriting, tool use, and so on. And the 1 billion checkpoint, of course, is smaller checkpoint, but still it's pretty competitive with Gemma. Okay. So the way the model is trained is basically by essentially by essentially doing these two things, pruning and then distillation. In fact, as you see, essentially you take Llama 3.1, not Llama 3.2, remember 3.1, right? The previous version, 8 billion checkpoint, Llama 3.1, 70 billion pre-trained checkpoint. You essentially give it some sort of pre-training data and get the logics from here and try to distill it down along with, so first you do pruning, so single shot structured pruning. And after doing the pruning, you essentially take the pruned checkpoint, Llama 3.2 checkpoint, and then distill it down to 1 billion and 3 billion checkpoints. Okay. So that's the first stage. Essentially, first stage of pre-training involves, of course, pre-training the Llama 3.2 models, but then also trying to prune them using single shot structured pruning. They do structured pruning and one shot, not an iterative pruning. And then essentially distillation from the teacher model, teacher logics, where the teachers are basically 3.18 billion and 70 billion models. Once this is done, they also do post-training. So post-training basically involves all the standard things like supervised fine-tuning, rejection sampling, and direct preference optimization, which are sort of standard across multiple versions of the Llama models now. Right? And while doing this post-training, they also scale the context length to 128K tokens. In the first phase of pre-training, the context length is shorter, but while doing post-training, they actually enlarge the context length, enhance the context length as well. Um, so the instruct model basically, which is trained as part of the post training, basically gets sort of distillation and inference, gets distillation and gets all the help using synthetic data prompts, but using the Llama 3.14405 billion parameter instruct model. Right? So that's how the instruct model is trained essentially. So that's that. Now, so as you see, there is a whole bunch of synthetic data that is being obtained using the instruct model, which is essentially used for various kinds of post-training things like DPO as well as supervised fine-tuning and so on. So that's how these text-only models are trained. Now let's talk about vision models. So how are the Llama 3.2 vision models trained? Well, they have two different checkpoints for vision, 11 billion and 90 billion models. And they basically also show that these models are actually pretty competitive with Claude 3, Haiku, and the GPT-4o mini models on various image tasks like image recognition and a range of visual understanding tasks. Okay. So the way they enable the vision capability in the Llama 3.2 model is by, of course, having a large language, the Llama 3.2 large language model, but combining it with vision encoder, image encoder, and the cross-attention layers. So while doing this vision-based pre-training, essentially they freeze the large language model, but they update the image encoder as well while training the cross-attention layers. Right? So the recipe is as follows for training. So they first pre-train Llama 3.1 with the image adapters and encoders on noisy image text pairs. So the first step, of course, they start with the Llama 3.1 LLM, and then they essentially add the cross-attention layers and also the image encoder. They pre-train the entire thing on noisy image text pairs. While later they essentially try to do the second step of pre-training on cleaner data and knowledge enhanced in-domain data. So the in-domain knowledge enhanced image text pairs based on which you basically do the second level of pre-training. Okay. Of course, just like text-only models, they also do post-training for vision-based models using the same SFT rejection, supervised fine-tuning, rejection sampling, and direct preference optimization. Lastly, just like they did in Llama 3.1, they also add safety mitigation data while doing post-training so as to ensure that it generates safe responses. But that's not it. I mean, to be able to ensure that there's a better level of system safety, they also provide Llama Guard 3 11 billion vision model, which basically ensures that the input and the output going to 3.2 is guarded for any kinds of offensive or or risky stuff, right? So it supports AMA 3.2's new image understanding capability and filters those input prompts or output responses which are offensive or incorrect or bad in any nature. So that's the Llama Card 3 11 billion vision model. Now, for the text-only models, they basically also have a smaller Llama Guard 3 model, just a 1 billion model, which is based on Llama 3.2 1 billion model. So the Llama Guard training, of course, they don't divulge too much details in this blog, but I believe it's going to be very similar to the one that they did in the Llama 3.1, the Llama Guard model that they released with Llama 3.1. So in Llama 3.2, they essentially start with the Llama 3.2 1 billion model and would have trained these, Llama Guard models on both positive and negative samples for offensive or any kind of bad data versus not. Right? So this one, Llama Guard 3, is a 1 billion parameter model, but it has been pruned and quantized to be much smaller, just for 438 MB checkpoint, so that it could be essentially leveraged and installed on edge devices as well. So how do these Llama 3.2 models perform? Okay. So there are two kinds of evaluations that they do. One is basically text-based evaluations, and the other is essentially multimodal evaluations. So the text-based evaluations, again, they perform evaluations across several data sets categorized into different broad categories like tool use, mathematical reasoning or general reasoning, long context handling, and multilingual handling. These categories more or less are also present in Llama 3.1 kind of evaluation. Yeah. And then they, of course, also deal with the general NLP benchmarks like MMLU, right? So what they observe broadly is that they compare Llama 3.2 model 1 billion and 3 billion with the Gemma 2 billion and 3.5 mini instruction tuned models, right? So these are both instruction tuned models in that senses. Okay, and what they observe is that uh, Llama 3.2 is clearly better compared to Gemma 2 on most of these tasks, right? So if you basically compare on most of these tasks, you'll find that Llama 3.2 is better than Gemma 2 2 billion parameter model, and their Llama 3.2 1 billion is typically worse. So 3.2 3 billion is better, but 1 billion is actually worse than the Gemma models. Right? Five models, well, they perform better in some use case in some of these benchmarks, but worse in some other benchmarks. So there's no clear understanding as to which is better, 3.2, Llama 3.2 or five models. But broadly, in many of these cases, you would observe that Llama 3.2 actually does somewhat better compared to 3.5 mini model as well. Okay. Now, for the multimodal or the vision benchmarks, again, they compare on various categories like college level problems in math reasoning, charts and diagram understanding, visual question answering, and they also perform an evaluation of these 11 billion and 90 billion checkpoints on text-only benchmarks as well, right? And they compare with the Claude 3, Haiku, and GPT-4 or Mini, right? And again, I mean, as you observe, Llama 3.2 90 billion is way better compared to 11 billion. So that's obviously the case. So across most of these benchmarks. But what you also observe is that if you really look at the Llama, the 3.2 90 billion checkpoint, well, it's way better compared to Claude 3 Haiku model, right? Way better compared to Claude 3 Haiku model in almost all of these benchmarks that you see here, right? It also is comparable with GPT-4 or Mini. So in fact, in most of these, some of these, scenarios, well, it's not really better, but most of the scenarios, as you observe, Llama 3.2 90 billion is sort of better or comparable with GPT-4 or Mini. Okay, here is a short, demo how image understanding, what kind of image understanding one could do with Llama 3.2 models. This is an interior design assistant. So there is an image that somebody can upload, and then Llama 3.2 model analyze the image and then basically says, hey, then image of a modern open plan living space with some large abstract painting. It describes the interior, and then it basically detects the objects and suggests alternatives. Basically says, hey, rather than that fireplace, you could possibly select one of these particular designs, and sort of comes up with a nice prompt for image generation models to actually generate images, or in this particular case, just the RAG models to retrieve interesting images, which are of a slightly different design, but still related to the original image that the assistant provided, right? So that's that. So these models, of course, don't generate images. They can retrieve images, so they can be combined with a retrieval augmented generation system to retrieve relevant images from a large repository. Okay. So in summary, in this video, I talked about Llama 3.2. So there are these, 4 different models, 1 billion, 3 billion, which are text-only models. And then there are 11 billion and 90 billion, which of course are vision LLMs, but of course you can also use them for text tasks. Pre-trained as well as instruction-tuned checkpoints are publicly available. And as we also discussed, they perform really well for 150 plus text and vision tasks. The smaller models actually beat Gemma 2 checkpoints on many of those benchmarks, and the vision-based models actually beat the Claude 3 checkpoints on many of these tasks. Right? So that's it for this video. Hope you liked it. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.